This is week 1, and this is our final set of videos, solving a quadratic equation. Now, a quadratic equation is any equation where the highest power of the variable is the second power. For instance, this equation, x squared minus 6x plus 8 equals 0. It's an equation because it has an equal sign, and the highest power on the variable is a 2. There are going to be a lot of examples coming up in a later unit. Here's another example. The highest power is a 2 on the x squared. The general form for a quadratic equation is ax squared plus bx plus c equals 0. So anytime we have an equation in this form or any permutation of this form where one of these terms might be on the other side of the equal sign, we're going to be able to solve it with one of two methods that we're going to learn in this course. The first method we're going to use is the factoring method, and in week 2 we'll learn the method with the quadratic equation, the quadratic formula. Alright, so we have some steps we're going to use. First, we're going to simplify the equation and add and combine any like terms. Then we're going to do plus or minus, or add or subtract, to get all terms on one side. So we're going to make sure that the equation is set equal to 0. We want 0 on one side and all the terms in the equation that aren't 0 on the other side. And then here's the important step. We're going to factor the equation. Remember that factoring into two binomials? That's what we're going to be doing. And then I'll show you, using zero product property, how we can solve the two mini equations we get. So let's go through the steps on this one. Let's look at the equation and see if it needs to be simplified. X squared minus 6x plus 8 equals 0. Alright, there's no like terms I can combine, and it looks as simple as possible. There's no GCF in each of these terms, so I'm ready to begin solving. So what we're doing when we're solving a quadratic equation is we're trying to find the value of x that when we times it by itself, in this case, and then subtract 6 times that number and then add 8 to it, we actually get 0. And there is such a number. And these are not easy to guess the number, not at all. So we definitely want some solving steps. So the next step is to do any operations, plus or minus, to get all the terms on one side. Well, we have all the terms on one side in this one and 0 on the other side of the equation. So this one's ready to go. We don't need to do step 2. Step 3, factor this side of the equation and set each factor equal to 0. Remember the factoring process? That's the baseball diamond. Remember what we do? We draw our baseball diamond, times sign on the top, plus sign on the bottom. We put the constant term, the plain number, at the top. We put the middle coefficient of the middle term, in this case it's a negative 6, make sure you bring any minus signs with, at the bottom. And then we're asking ourselves, what factor pair multiplies to make 8, a positive 8, but adds up to negative 6. Now, when I think of factor pairs of 8, I always think of 2 and 4 first. 2 times 4 makes 8. And think about it, if we make that a negative 2 and a negative 4, a negative times a negative is positive, and negative 2 plus negative 4 equals negative 6. Now, but don't be upset if you don't get these as fast as I do. I've had a lot of practice at this. Sometimes you really have to list the factor pairs and play around with them. But keep it up till you find the right factor pair. Now remember how this works. The x goes here and here, so that when I multiply these back out in my head, I get the x squared. Then you take your two corners of your baseball diamond, the third and first base, and you put one of them here and one of them there, with their sign in front of them. If I multiply this back out, I get this. These are two equivalent equations. This one I don't know how to solve. This one I do, and here's why. This says some number times some other number, once I know what x is, should give me 0. Now think about it. What times what makes 0? What has to be true about two numbers that make 0? Let's look at a few. Let's look at some number sentences where we get 0. How about 5 times 0? That makes 0, right? How about 0 times negative 7? That makes 0. How about 0 times 0? That makes 0. Notice the pattern. At least one of the numbers being multiplied has to be 0, or both of them. Okay? So let's go back and see what that means for our little equation here. Here's where the multiplication is going on. So again, we have some number times some number. This is some amount we don't know yet, and this is a different amount. Either this amount or this amount is going to have to equal 0 in order for this equation to be true. So at this point, here's what we do. We set up two mini equations from our two binomials. We set up x minus 2 equals 0 or x minus 4 equals 0. Actually, it's and, because either one of these can be true. Okay? And once we solve this, we should have a number, two numbers in fact, that work to solve this equation. So here we go. We're going to solve this mini equation first. What minus 2 equals 0? Well, obviously 2 minus 2 equals 0. I know that because if I undo this equation using the reverse order of operations, I get x equals 2. What minus 4 equals 0? Duh! 4 minus 4 equals 0. If you can't see that, then use your equation solving technique, undo minus 4 with plus 4, and I get x equals 4. This equation has two solutions. It has two solutions. Here's why. X squared is the answer, is the key to why there are two solutions. Usually the highest power of the variable in the equation will tell you how many solutions there are. Since this is to the second power, there are usually two solutions to a quadratic equation. Back when we were solving linear equations, the x's are to the first power, and this is why we have only one solution at most. Alright, take a second to rerun the video on this problem if you need to, and then tune back in for the second one.